Welcome, everyone. This is Jeffrey Wu with the Health Via Modern Nutrition HVMN podcast. And today I'm joined by my colleague, my science hero, HVMN's research lead, Dr. Latt Mansour. Welcome back on the program.
Hi, Jeff. Thank you very much. How's it going?
Doing well. I'm actually at my parents' place down in California. It's great to be back in my childhood roots. California air is great, but going to be back in Miami, Florida very, very shortly. And I know that you're going to be traveling out there for some interesting meetings with scientists, with folks in our community. So very much excited to see you in person very shortly.
Yeah, it'll be exciting to visit Miami for the second time in my life next weekend. So that'll be quite fun. So we'll catch up then.
Perfect. So I think one of the things that we've been doing a lot is really diving into the research roundups. And I think this is one of our most interesting regular pieces of programming because one, not a lot of just discourse is done on the research coming out of exogenous ketones for different indications. So I think it's an interesting set of people that one, have the background to interpret such studies, and then two, be on top of the latest research, because I think a lot of the existing literature ends up being quite outdated because this space is one of the most exciting spaces of research in metabolism, in physiology. So it's constantly updating. And my opinions, and I think your opinions and your view on the space has quickly evolved. So very happy to dive into another exogenous ketone paper today with you.
Yeah, as you said, the space is expanding really quickly and really into a lot more areas than we thought exogenous ketones has a role in. So today we are actually not talking about athletic performance or ergogenic effects. In fact, we are talking about heart failure and myocardial infarction and exogenous ketones in playing a role in mitigating that.
Yeah, exciting. And I think this is a particularly interesting space because one, the ketogenic diet has been somewhat demonized by cardiologists because of the requirement to have high fat consumption. So it is interesting from an exogenous ketone perspective where you can decouple having a ketogenic diet with the presence of ketones in the system. So one, I think that's very exciting. And then two, there's been some literature recently around, hey, are ketones good for the heart or bad for the heart? So this is a very, very recent paper published just earlier this year. Latt, do you want to introduce the paper, the authors, the background here?
Sure. So the paper is entitled Ketone Ester Treatment Improves Cardiac Function and Reduces Pathologic Remodeling in Preclinical Models of Heart Failure. So essentially, this paper combines two different animal models using two different exogenous ketones in investigating the role of ketones in heart failure and myocardial infarction. So the first study used mice, 53 mice were on, they call KE1 diet, which is the first exogenous ketones. And that is the hexanoyl hexyl 3-hydroxybutyrate. So to clarify that, it's two C6 molecules bound to a BHB molecule. So that is a ketone ester. And the second study, 77 rats, instead of mice now, 77 rats were treated with beta-hydroxybutyrate 1,3-butane-diol monoester, the ketone monoester that we are very familiar with. And that is more towards heart failure. So this is very interesting, when we look at two different animal models from two different research groups, as well as two different exogenous ketones. And this way we can actually, conclude, is ketone actually good for the heart, during instances of myocardial infarction and heart failure?
Yeah, very cool. So essentially, I think it's like one, decoupling ketogenic diet from the presence of exogenous ketones. And then two, are there particular benefits of specific forms of exogenous ketones? And it's really cool here that, HVMN supplied the beta-hydroxybutyrate butane-diol monoester. And the second ketone diester that was tested was hexanoyl hexyl 3-hydroxybutyrate diester, right? So again, one thing that people will start getting more and more familiar with as the space unfolds is that there are multiple types of ketone esters. And I think in, folks that are more new to the space might think, oh, there are MCT oils, there are ketone salts, and there's ketone esters. Now, I think if you actually unpack that within MCTs, there's multiple types of medium chain triglycerides, right? C6 or C8, which is called caprylic acid, is forms of an MCT. Ketone salts, there's sodium BHB, magnesium BHB, racemic salt, or chirally pure D-BHB salt. These are all ketone salts, but each of those different molecules are very different. And naturally, ketone esters were very, very cutting edge 2, 3, 4 years ago. But as the space has developed, there are now multiple forms of ketone esters, ranging from the beta hydroxybutyrate R13-butane diol monoester that HMN first brought to the market back 3 years ago, 4 years ago, right? That is the product that we help break world records with, supply a lot of athletes, et cetera. But within the interim period, there's also work coming out of a lot of Dom D'Agostino and his group's work coming out of with acetoacetate diester, which is another ketone ester. And in this paper, there is the C6BHB ketone diester, which is a relatively new diester that is now being brought onto the market. So very exciting to unpack and see the differences between all the different types of ketone esters. Before diving into the protocol, I want to shout out, where was this research done? Which research groups? I see a couple familiar names. I see John Newman. I see Eric Verdun. They are friends and colleagues over at the Buck Institute, which is very near our San Francisco former HQ. Any other researchers that we know or groups that we know?
So John Newman's group, Dan Kelly, Eric Verdun, that group, as you said, they're from Buck Institute. They are responsible for the mice study using the C6 diester. And the other group that is responsible for the rat study is from the Department of Cardiology, University Medical Center Groningen in the Netherlands. So these two groups collaborated and combine their studies and their findings to publish this paper.
Cool. So before diving into the specific methods, I think it's just good to paint the broad context on why ketones and cardiovascular health and heart disease or heart health is associated. I think even just a lot of the podcasts, right? We talk about what is considered heart healthy. And the traditional AHA, American Heart Association, usually they talk about, you see that AHA stamp on Cheerios or different carby breakfast meals versus what is more in the ketogenic line of the school thinking, which is, hey, actually reducing insulin, increasing insulin sensitivity, reducing the presence of glucose potentially is much better for heart health. And the mechanisms have been debated, but one of the leading suggestions or hypotheses is the presence of ketones that offers this cardioprotective ability. So I think this study is a very useful study that helps unpack, what of a ketogenic diet is potentially helpful for heart health. Is it the restriction of carbohydrate? Is it potentially calorie restriction? Or is it the presence of ketones themselves? So I think that is a specific key question that I'm excited to learn about from this study. Any other broad background context that is worth offering before we dive into the methods here?
No, I think you've pretty much covered it all. I think a lot of concern, as you said, cardiologists are very concerned about the high-fat diet, about ketogenic, having that sort of high fat, and the fact that a lot of people are not making informed decisions around the choices of fats that they're consuming may increase the risk of atherosclerosis and therefore increase the risk of myocardial infarction. So this gives us a really, standalone point of view, the role of exogenous ketones or ketones in general or BHB in general in helping or in having any sort of play around cardiovascular disease.
Perfect. So let's learn. Let's learn here. So let's talk about the methodology here.
Sure. So for the mice, they were on C6BHB diester a week before surgery. And the surgery consists of anesthesia, intubation, and intercostal thoracotomy, as per the TAC myocardial infarction procedure, and had the aortic constriction of coronary ligation. For the rats, on the other hand, 77 male Sprague-Dawley rats were randomized to the BHB butane diol monoester treatment before surgery and as well as 2 weeks after surgery. So in the second study in the rats, they looked at both pre-surgery effect of ketones and as well as after heart failure is being induced on the effects of ketones on the remodeling of the cardiac tissues.
Got it. And then just for clarity, the surgery is basically just inducing a heart attack.
Yes.
So basically, these researchers were basically doing a surgery to cause heart attacks for the C6 BHB diester a week of being on a, kind of this exogenous ketone diet. And then for the BHB butane diol monoester, there was two arms. One was 1 week before, and then one was after, 2 weeks after. So just like a couple different looks at how ketones, particularly two specific forms of ketone esters, are able to deal with heart attacks. Cool. Exciting. I mean, I want to know the answer. So what happened?
So first of all, in terms of difference in the exogenous ketones, the C6-BHB diester actually cause less of a ketonemia during the non-feeding period. So basically, they added in these exogenous ketones in their normal diet, and rats are nocturnal, mice are nocturnal, so they eat during at night. And fair enough, both ketone esters, both exogenous ketones did induce ketonemia during feeding period. However, only the BHB butanediol monoester that caused ketonemia throughout the non-feeding period, which is what I find quite interesting. So different types of ketone ester will sustain different length or duration of ketosis. And this is what they have shown us.
Yeah, I think just practically speaking, basically, another way to say it is basically the BHB butanediol monoester is better at keeping ketones elevated throughout the night, where the C6 BHB diester popped it up a little bit, but as it metabolizes away, the ketones quickly get metabolized and disappear from the system. So it is closer to ketone salt efficacy, which also dissipates quite quickly versus the classic BHB butane diol monoester. So just from a PK or pharmacokinetics perspective, looks like it's pretty clear here that the BHB BDO monoester is superior both from a longitudinal and spike of ketones compared to the C6 BHB diester.
Yeah, you're correct. Another note here, though, is that they dialed back on the dose of C6 diester. So that might play into the role of why ketosis is not being sustained much longer as well. But obviously, they can't go any higher because the mice start losing weight.
They were causing weight loss.
Correct.
Yeah. So I think, again, rats are very different from humans, but I think this is something to consider as, these become potentially translatable to, human application, is that, as we're looking at different possibilities or different ways to induce exogenous ketosis, I would just be more concerned just with this data set here of why is C6 BDO causing weight loss, unexpected, unintentional weight loss, and without much of the gain of having high ketones. So it looks like, again, from this specific data set, if cost is of no concern, if availability was of no concern, it looks like C6 BHB to me is just like an inferior exogenous ketone molecule. I think that's just, if you look at this specific data set, hard to argue, off that point.
Agreed. If you just take, face value, just the facts on its own with the data from this paper, you are correct. Definitely. So let's look at the effect on myocardial infarction and cardiovascular disease per se. So in the mice, C6 diester, following the myocardial infarction surgery, cardiac hypertrophy was significantly attenuated in mice fed with a C6 diester compared to chow-fed mice. Now, that means cardiac pathology remodeling was improved in these mice that were on C6 diester. Now, why are we talking about cardiac hypertrophy when we were talking about myocardial infarction? So what happened is that essentially when you have that surgery to induce heart attack, the heart will start remodeling itself in order to compensate energetics, metabolism, and try to grow bigger, so cardiac hypertrophy, to make sure that it has enough sort of force and contraction as well as energy to supply to the heart in order for it to keep pumping. So this is a very common sort of symptom or common telltale sign of people sort of having high risk of developing heart attacks.
Got it. Cool. So do we have a parallel data set for the BHB butane diol monoester?
That I think they look at slightly different things. They didn't look at hypertrophy per se. They did look at ejection fraction though. So we will talk about that in a bit. So impairment of left ventricular function is a major predictor of mortality after acute myocardial infarction. So the impairment of left ventricular portion of your heart is actually a very strong predictor for mortality after myocardial infarction. And this is being shown or indicated by ejection fraction. So that's how the function is being defined. So in this case, in the mice with C6 diester, they saw the attenuation of impairment. So if you look at figure 2D, the ejection fraction definitely went down. It got decreased after the surgery, so after myocardial infarction. But then in the C6 diester group, it actually went up significantly compared to the chow-fed mice. So this shows the role of ketones in mitigating that, not 100% back to normal, but it's definitely more significant compared to a non-ketone group.
Cool. And I also, just to look at the numbers here, it went from a left ventricular ejection fraction mean of 36 to 45 in the BHB or C6 BHB diester. And that same metric was measured in the rats for the BHB butanediol monoester, going from a left ventricular ejection fraction of 41 to 61. So in that sense, regardless of which type of ketone molecule gets consumed, ketone seems to be quite cardioprotective in terms of recovery from a myocardial infarction or a heart attack. And then, is there a difference in terms of having the ketone before versus after?
Perfect question. That Salva Yurista's group from Netherlands actually looked at that, as they gave the butanediol monoester before surgery and continued 2 weeks after to look at the before and after effect. So let's dive into that. So I think the main finding here they call it the early and late treatment. So early means, if you look at the diagram, figure 3A, you start the diet just slightly early before the surgery, and late is after 2 weeks of the surgery. So it seems like there is not much difference between treating these rats earlier versus later, but both groups actually showed some significant improvement in cardiac remodeling as well as recovery from the surgery. So we can dive straight into the results. So in terms of the cardiac function, there is improvement in cardiac function and there is a reduction in cardiac remodeling. Any questions, any comments on that, Geoff?
I'm just looking at the graphs on figure 4, and it looks like earlier is a little bit better than late, but both are better than chow, which makes sense. Having ketones in your system before you get the heart attack, it's just right there and there, versus having to supplement a little bit after the fact. And that I think is a good translation point, thinking about how we might interpret this for, people. Potentially being on a ketogenic diet is cardioprotective as you potentially go into a heart attack, and having ketones in your system through exogenous ketones might be better than waiting for the heart attack and then supplementing with ketones after the fact. So that would be what I interpret from the study, which is that better late than never, but might as well just have ketones in your system if you are prone to having a heart attack.
Yeah, if you're already at high risk. And another point that they found is that the BHB monoester resulted in significant reduction in both ventricular weight and cardiomyocyte cross-sectional area. So in some sense, it sort of attenuated the hypertrophy as seen in the mice with the C6 diester. What is also very interesting here, Geoff, the BHB monoester slightly improved the left ventricular ejection fraction or function in the sham group. So sham group essentially is the group that went through the surgery but didn't actually go through the ligation. So this is a sort of control for the surgery group.
So not a heart attack. It was just like they opened up the rat but didn't give a heart attack.
Correct. So even that, it seems like exogenous ketones improve the left ventricular function without being in a disease state, which is quite interesting.
Cool. So, I mean, essentially, it's not just necessarily cardioprotective after a myocardial infarction or heart attack. It might be just beneficial to make a normal heart even healthier, which is very, very cool. Any other specific points before we move on to takeaways and conclusion?
Yes, there is one more point. They looked at the genes and receptors that are related to ketone metabolism. So the expression of the gene encoding MCT1, monocarboxylate transporter 1, the main transporter for ketone bodies entering cardiomyocytes, was increased in the chow rat group compared to the sham chow group, suggesting that myocardial infarction, the heart upregulates ketone transport regardless or independent of the availability of ketone in the body. Again, so myocardial infarction, they saw upregulation of genes that regulate ketone metabolism and take in ketone metabolism independent of ketone availability.
Interesting. So that is interesting from a mechanistic perspective. It seems to be the natural response from a heart injury that the body already responds by upregulating ketogenesis, which makes sense. That like then when you actually just put in ketones from with either form of ketone ester, it improves outcomes tremendously. So I think this is super exciting, right? I think one, it recapitulates some of our initial hypotheses and frameworks of ketones and ketogenic diet being cardioprotective. And it looks like the ketones themselves offer a lot of that benefit, right? So if there was an argument or discussion around is what of the ketogenic diet is beneficial for the heart, it looks like the ketones themselves are a dominant mediator for that function, meaning that you can just have ketones in a drink form and you get a lot of the cardioprotective benefit. And then two, now it's like, a really good study that really looks at one, the mechanism of explaining a little bit of why this seems to improve. And then two, get metrics in terms of just actually measuring functional outcomes, right? I think left ventricular ejection fraction is a great real world metric. It's not some random biomarker or some random gene expression that's hard to interpret into everyday function. No, this is actually your heart ejecting more fluid or more blood, which is ultimately the metric that we all care about.
And on that point, Geoff, on that left ventricular ejection fraction point, the a group from Groningen actually also measured left ventricular ATP. If you look at figure 6, they showed that ketones actually increase the left ventricular ATP generated in the group after myocardial infarction. So that in its own, it's so interesting because ketones is actually generating more ATP compared to the chow fat group. And, this sort of enforces our understanding that ketones may be more energetically beneficial when there is some form of disease or occurrence that stops the cells to generate more ATP. For example, ischemia, hypoxia, these kind of situations where the cells or the organs are struggling to generate ATP from the conventional fats, proteins, glucose. Ketones may actually be the answer to provide the ATP needed in order to keep operating these organs.
Yeah, no, that's cool. Again, that's another specific biomarker that's very, very understandable, right? And I think one of the general critiques that I have around biology is that oftentimes people measure these proxies, whether that's gene expression, but they don't actually measure the end functional endpoint, right? Like how much ATP is actually generated, how much ejection fraction is actually, how much blood is actually being moved. So it's cool that this paper seemed quite robust in measuring some of these functional attributes. Cool. Yeah. I mean, any conclusions, recommendations of how our audience might be able to take this away? Again, I would say the caveats are, I can start and then I'd love to have you kind of wrap up. Is that one, this is an animal study, right? Humans are not animals. So maybe none of this is translatable. But I think, especially for this specific model, I think inducing a heart attack or doing heart damage seems pretty relatable. Like cardiomyocytes and hearts generally function very similarly from mammals. So I think in terms of translatability, this is one of the better ones, right? I think brain, I think other like longevity, these more complex endpoints, a little bit harder to interpret and translate. But I think for heart, this is much easier for me to translate from animal model to human model, but have to make that disclaimer that this is rats. So don't necessarily take this for, take this within the holistic body of evidence that we can all read. But two, I mean, I generally, it reinforces the optimism that I have for ketones as being a beneficial part of everyone's diet. And you can get there through fasting, you can get there through eating ketogenic diet. And it looks like very clearly here that exogenous ketones, whether it's in the form of BHB, BDO monoester or C6-BHB diester, there's very efficient ways to induce ketosis safely. I would say the BHB BDO seems safer than the C6 BHB, just given from the weight loss perspective. But both are equally effective in terms of improving heart function after a heart attack. So if I were, this is just personal opinion, personal practice, would worried about a heart attack, I would be very, very thoughtful about thinking about incorporating ketone drinks into my daily heart health protocol. I think the data here is like pretty compelling for that.
Yeah, and great point on the caveat that this is an animal study. I, as a basic scientist, we always use animal models to find out mechanisms, to find out proof of concept and all that. But we always get the question from clinicians and from the public, how is this translatable? So that is why I chose our next research roundup paper to look at clinical settings and exogenous ketones in cardiovascular disease. So stay tuned for that one. And in terms of discussion and takeaway points here is that even though this paper showed there is no difference in infarct size between the different exogenous ketones, there is definitely significant improvement in the remodeling as well as the attenuation of cardiac dysfunction following the infarct of heart failure. And it also seems that when the heart goes through heart failure or myocardial infarction, it does change the metabolism of the heart to switch off or switch or lower the metabolism of fatty acid, which is the primary fuel for a normal heart, to glucose and other substrates. My sort of understanding is that because the fat metabolism may increase the oxidative burden of the heart recovering from the myocardial infarction. So it seems like ketones does actually improve the redox state and mitochondrial membrane potential, as well as proton motive force for ATP synthesis in these sort of studies. So that is very important in terms of mechanism of how ketones may help with the recovery after heart attack. Another point here I want to make is that the hypertrophy following a myocardial infarction, yes, it has been attenuated by ketones, but we still don't know whether it's due to the BHB signaling effect, or is it due to the improvement in energetics caused by the availability of ketones, or a bit of both. So that is something I personally would be interested to find out more, from these research groups as they unpack and peel off all these layers before we get to the bottom of the knowledge here.
Yeah. So hypertrophy, meaning the bigger hearts, right? So with the ketones, you don't see that increase of the heart size, which is interesting to interpret, right? Because, yeah, I think to your point, is it because the ketones cause the heart to be more efficient? So you don't need extra growth of the heart after that injury. And I think that's one of the interesting questions, because obviously athletes have larger hearts because, you're using the heart more. But at a certain point, it's also like too large of a heart is also not great either. So I think this is interesting from an injury context. Is hypertrophy good or bad here? And I think that this is an interesting thing that's a little bit hard to interpret.
Yeah. Well, in this case, the hypertrophy was definitely caused by the stress that the heart is facing because of ischemia and hypoxia. And that, to a certain extent, it is definitely not good because it's overcompensating and trying to figure out how to keep surviving. Unlike muscle hypertrophy, which, a lot of us trying to work out, like we want to give the stimulus in order to build the muscle and build strength. But in this case, it may not be the best situation. So in terms of application, as you said, Geoff, I totally agree. If you have a higher risk of heart attack, if you have a higher risk of cardiovascular disease, and I would like to have cardiologists actually look at this paper and say, would it be beneficial to give exogenous ketones to people who have just been diagnosed myocardial infarction or unstable angina, even to mitigate whatever damage that comes afterwards? So, I am not a clinician, so I would love to get a point of view from a clinician, a cardiologist, to see what are the prospects here to help people survive a heart attack. and heart failure.
Yeah, so I think I'm excited to do our next research roundup, which takes the ketone treatment to a clinical setting with humans and help answer that question. Again, I think what we see here is very, very promising, that this is potentially very useful for frontline treatment, potentially. But of course, work to be done and not to get overhyped on the potential here. But I think the bones are very exciting and the mechanisms make a lot of sense. So we'll leave it at that. As always, thank you so much for tuning in. We appreciate the like, subscribe, bell button, whatever format you're receiving this podcast. Latt and I appreciate your thoughts. Feel free to share to friends, especially those who are concerned about their heart health or heart attacks. This might be something that's useful for them to incorporate, or ask their primary care practitioner how they might be able to interpret this and incorporate that into their lifestyle. Until then, talk to you guys all very soon. Thanks so much.